Welcome to What's Next. What if I told you the planet is hungry and getting hungrier every single day? Not hungry for food, hungry for energy. Is the Earth's hunger for energy actually dangerous, or is it just the natural pulse of human progress? Imagine the Earth sitting at a giant table, devouring plates filled with coal, oil, and natural gas. And the strange part? The appetite keeps growing. Between 1950 and 2000, global energy production didn't just grow, it quadrupled. In just 50 years, humanity multiplied its energy consumption by 4. But here's the twist. Not everyone at this global dinner table is equally hungry. Some countries are already full and trying to go on a diet. Others have just arrived, and they are starving for growth. Today, we're going to understand the pressure of energy demand, the difference between industrial and emerging nations, and the environmental challenge that comes with it. And along the way, we'll confront a deeper question. Can prosperity exist without endless consumption? We can divide the world into 2 broad categories. First, industrial countries, the United States, Japan, Europe. These nations turned on their economic engines decades ago. They built their infrastructure, their industries, their highways, their power plants. Second, emerging countries, China, India, Brazil. These are giants that have recently awakened. They are building cities, factories, transportation systems, and lifting millions out of poverty. To hear a simple analogy, think of the industrial countries as a wealthy middle-aged homeowner. The house is built, the car is purchased, the goal now is maintenance and optimization. Emerging countries are like young, ambitious entrepreneurs. They are building everything from scratch. Homes, industries, transportation networks. Of course, they need more raw materials. Of course, they need more energy. If you look at figure 1-4 in the book, the contrast becomes clear. Up to 2004, energy consumption in industrial countries remained almost flat. In some cases, like Denmark, energy use barely changed between 1980 and 2004, but the line representing emerging countries shoots upward like a rocket. This is not greed. This is development. When people gain property, build businesses, and improve their living standards, energy demand naturally rises. Energy is the tool that transforms effort into productivity. Now let's focus on 2 giants, China and India. Figure 1-5 compares energy consumption among major players, the United States, Europe, Japan, China, and India. In the late 1980s, US and European energy consumption were roughly equal. After that, Europe took a different path. Through efficiency improvements and technological upgrades, Europe managed to control its growth in energy use. The United States, however, continued moving forward at a faster pace. But the most dramatic story is China. Look carefully at the curve. Between 2002 and 2004 alone, China's energy consumption jumped so sharply that it reshaped the global trend. This was not random. It was the visible sign of industrial acceleration. To really grasp how fast technology evolved in China, just look at these 2 images. A steam locomotive in China in 1989 and a high-speed maglev train in 2006, only 17 years apart. That transformation represents something profound, the shift from traditional production to modern, energy-intensive infrastructure. When a society industrializes, energy demand explodes, not because people are wasteful, but because factories, transportation, housing, and digital infrastructure all require power. Now here's a crucial question. Is it possible to become wealthier without constantly increasing energy consumption? This is where the concept of decoupling appears. For decades, we assumed that GDP growth required proportional growth in energy use. More wealth meant more fuel burned. But something interesting happened in the United States after 1996. As shown in figure 1-7, GDP increased by about 30%, while energy consumption rose only by 7%. That is a partial decoupling. Why did this happen? Several reasons. First, the rise of the information economy. Instead of producing only steel and heavy materials, companies began producing software, digital services, and online platforms. A data center consumes energy, but not nearly as much as a steel mill, yet the economic value created can be enormous. Second, telecommuting. When people work from home instead of driving daily to an office, fuel consumption drops while productivity can remain high. Third, efficient technologies. Incandescent bulbs were replaced by LED lighting. Appliances became more energy efficient. And fourth, a very important engineering point, outsourcing. Energy-intensive manufacturing was moved abroad, especially to China. The smoke rose in Asia, while a significant portion of the profits flowed back to American companies. This shows something important. Economic structure matters as much as energy volume. Innovation, property rights, and technological freedom allow societies to create more value per unit of energy. But there is a darker side to this story: carbon dioxide. In Figure 1-8, we see a surprising moment in 2004. For the first time, emerging countries, despite consuming less total energy than industrial countries, produced more CO2 emissions. How is that possible? The answer is efficiency and fuel mix. Industrial countries, on average, emit about 53 kilograms of CO2 per unit of energy consumed. Emerging countries emit around 69 kilograms. Why? Because many of them still rely heavily on coal and older technologies. The relationship can be summarized in a simple formula: emissions equals energy times emission factor. Total emissions equal the amount of energy consumed multiplied by how dirty that energy source is. For example, burning 100 liters of gasoline in a modern 2024 engine produces far less pollution than burning the same amount in a 1970 engine. Technology changes outcomes. This is where the real challenge lies. The world wants development, and rightly so. Individuals in developing countries deserve reliable electricity, transportation, and opportunity. But the method of energy production determines the environmental impact. As the final topic of this episode, we explore two philosophical paths for the future. The mainstream view says maintain modern lifestyles, but clean the technology. Electric vehicles, solar panels, cleaner fuels, better efficiency. The deep ecology view asks a more radical question: why consume so much at all? Why not fundamentally reduce demand, build smaller homes, travel less, and simplify life? This debate is not just technical, it touches economics, culture, and personal freedom. One path emphasizes innovation and cleaner production. The other emphasizes restraint and lifestyle transformation. The future of energy will likely depend on how societies balance prosperity, environmental responsibility, and individual choice. So, what have we learned? Global energy demand is under pressure, especially from emerging economies that are striving for higher living standards. Industrial countries have slowed their growth in consumption, partly through efficiency and structural change. Carbon emissions depend not only on how much energy we use, but how we produce it. And technology remains the most powerful bridge between prosperity and sustainability. In the next episode, we'll dive into one of the most important foundations of energy engineering, the common language of engineers: units and measurements. Because if we don't understand the units, all the numbers in the world are just meaningless symbols. Subscribe, stay curious, and let's continue exploring the energy that shapes our world.